Hello everybody, welcome to the part 2 of solving edit distance from Leetcode. I'm going to check if I'm already streaming. Apparently I am. And there's nobody here. There's always somebody here. Okay. So, where were we? We were thinking why the solution can go from the first space to this space to this space. The thing is, it's not like they are building the string. They are seeing their comparing if the changes to the string create the other string. It's not building the string. Is seeing what are the changes. So that's why you don't need to. That's why you can start from one, and you don't need to start from any place to see what is the best path. That makes sense, at least to me. Okay. So we are building the modifications of the string, not really the string. Now let's check the algorithm. So horse and Ross. What I need to do is see if these two are equal. So how is it called? The distance. But you can see that there. We have to see if word 1 in I equals word 2 in J. If it's equal, okay, we're going to solve this with memorization. let's say memo. So if this happens, the solution is memo of I minus 1 j minus 1. So because let's say this starts for empty, and I'm going to check. I have a string and I'm checking this place. If this is the same as this one, then I go to the part before, and that's the solution. Okay, so this is correct, and let's just implement that. So let's implement that. Let's go main distance. I need to define memo. So memo is equal for x and y. X equal to x and y. So for blah blah, If they are different, let's put that here. Else. I have a string and another string, and this one is different. What I need to check I need to put a min of removing or changing or adding. Moving or changing or adding. If I have the matrix, this one is Y, this one is X, and I, J. Removing is the same. Removing is I minus 1 J. This is the removing. Replacing I stay here and I go backwards. This is correct. Replacing is IJ. Okay, I'm a little lost. Let's check the solution again.
Last character has to be yn in this. So we will insert yn. Is marked in red. It now becomes ROSE, which is very close to this now. And now once we delete this E, this becomes ROS. So we had done 3 operations. One is substituting H with R. Next is deleting R and E. So in total, 3 operations are required. There can be other ways of doing that also. Let's say you delete these 2, so 2 operations, and you replace this S with, looks like this is the only way. So you have to find the minimum length is M and here it's N. That means X has M characters and Y has N characters, and we are asked to find edit distance. Let's call it ED MN. So this denotes take the first M characters of X and N from second string. So there can be a few scenarios. If you look at the last string, last character, these can be either equal or non-equal. If these are equal, then your job is reduced. So you have 2 strings, their last characters are same, and you have to convert this to this, and this matches. So what you will try to do in the remaining m-1 characters, if you can convert the remaining m-1 characters to this n-1 characters, then your job is done, since the last character is already same. So depending on that, we can have a few scenarios. So if x m-1 is equal to y n-1, then what we will do, we will return ed m-1 n-1. So without even doing any operations, this one string, one character is done for us. So we will not count any operation here. Else, that is they are not equal, then we will do those 3 operations. What are those? Substitute, delete, and insert. These are the 3 operations possible, which we will try all of these in this else case. So if we do any of these, we count it as 1 operations. So what things we can do? These are not equal now in this case. So what we will do, either we will delete it. We cannot delete this string is fixed. This is the target. So either we delete it and see that we are left with this m-1. So convert this m-1 to this complete n string. Here we have not even got a single character, so this remains complete. So it will be ed m-1 n. So here n does not change. M changes, we have deleted it. So let's mark it deleted.
Okay,
we have
so
to take min of these.
Really
what are the operations? This is for deletion, first one.
Then
we will substitute. So what we will substitute? So these characters are different, and our target is that last character should be this one. let's call it yn, and this is xn. So we will substitute xn with yn so that this character now becomes same and our task is reduced. So we will look in this m minus 1 and m minus 1 since we have substituted this to exactly what it should be. But the difference between this and this case, here also we are finding m minus 1 and m minus 1, and here also we are finding that recursively. But the difference is that here 1 is added because we needed to substitute this to yn to make them equal, and here we already had that equal, so that's why here 1 extra operations. And what is the third possibility? We have looked at substitution, deleted, then we insert. Third case is that we insert a character in the end, and that character should be same as this yn, otherwise why would we insert that? Last character has to be yn in this, so we will insert yn. It was not already yn, it was different. So again we have one operations, and once we have inserted yn here, this string becomes of size length m plus 1. It had m, we inserted 1, it became m plus 1. But last character we don't need to worry about, since that last character is same as this last character, that is what we have inserted. So we will not consider that for our next solution. So we will again be left with m characters only. The last one that we inserted equal to this, we are done with that. So here m will remain same and this n will reduce by 1. Since now this character matches with the newly inserted one, we have to look only in this part. So convert this.
Okay. If I delete it, I just go in the X. If I replace it, this one is solved, so I go behind, but I put I do a plus 1. I solve the same X. Okay. Okay, first let's do it recursively. Memo and nothing. Okay, if the last character is equal, then I do return word 1, word 2, n minus 1, k minus 1. If it's different, I do the mean between. This one is deleting in X, deleting in word 1. So I deleted. I deleted. So I need to take care of only the X. Deleting. This is changing. Not deleting, not changing, replacing. This is adding. Okay, I will come back